I miss a parenthesis, right? Parenthesis here. So it's a demand parenthesis P of tau, and there is a parenthesis. I just missed one. Okay, please add it to your slide. Without taxation, we say at equilibrium, demand at the equilibrium price would equals the supply, quantity supplied at P0, right? So for the equilibrium price, the quantity demanded equals the quantity supplied. This case is about no tax case. Okay? No tax. But now with tax, tau. P1, the quantity demanded at P1, the quantity demanded would be this Q1, okay? So this is Q1. And supply, which price can make the quantity supply equals Q1? Supply, not supply plus tax, supply. Which price can make the quantity supply equals Q1? So Q1 hit the supply curve corresponds to what? P2, is that right? Is that right? So this would be P2. And they are equal. Is that clear for you? Q1, when Q1 hits demand curve, the corresponding price would be P1. When Q1 hits supply curve, which led to the price P2. Okay? So demand of P1 equals Q1, supply of P2 equals Q1. And demand P0 equals Q0, and supply of P0 equals Q0. Okay? So you see, when there is no tax, the price, this is the price the consumer pays. This is the price the seller receives, right? And when there is a tax, tau, P1 is the price the consumer pays. P2 is the price the seller receives. And there is a gap between P1 and P2. There is a gap between P1 and P2 because P2 is P1 minus tau. Is that right? P2 is P1 minus tau. P2 is P1 minus tau because the size here is tau. Okay? Now, that is the reason why we have demand of P of tau equals supply of P of tau minus tau. So here P of tau is actually the P1 on the blackboard, and P tau minus tau is what? Is actually P2, right? And now we have a question here. Why the price paid by the consumer is a function of tau? Why? Do you think it makes sense? Does it make sense here? P1 is a function of tau. Do you think? What do you think? Make sense or not? So what is tau? This is the supply. When tau is look like this, in this size, then we have a P1. If we have a larger tau, stop here, when the tau gets larger and the shift of the supply curve more upward, right? So the intercept or the cutting point corresponds to a higher P1, right? Is that clear? So P1 is actually a function of tau. So you buy the logic. Do you buy the logic? Do you accept the logic? Which means, do you buy it? Okay? Ooh, math. Now we have a equation. Quantity demanded when the price P of tau equals quantity supplied when the price is P of tau minus tau. So this is P1, P2. And we just differentiate the equation, total differentiation of the equation with respect to tau. So how does tau affect both sides? Tau affects P, P affects quantity demanded. Tau affects P, P affects quantity supplied. And tau affects quantity supplied. And actually, it's not very difficult here. So dP, because there is only one argument in the function, one variable in the function only, and it's a chain rule, so P tau or P prime dP d tau, okay, equals the supply. I want you to note here, it should be by P2, but we call this as an argument P. So we just put it supply. How does supply affect by P? And chain rule, it would be dP d tau minus 1. So remember the very first thing is the quantity demanded. Quantity demanded is a function of dP. The quantity supply is a function of SP. So for these two functions, P, the price, is the only variable, the unique argument of these two functions. So although you see the value in the function the values are different. For the first one is P1 and is P2. But for a function, it's a price just located at a different level. So it's a price at the level P of tau. It's a price at the level of P of tau minus tau. But as an argument, as a variable, the way they affect supply or demand doesn't matter. I mean, in the differentiation form, it doesn't matter. But actually, this term or this item is evaluated at the point of p tau, and this is at the level of p tau minus tau. Is that clear? So by formula, you see dd dp, you see ds dp. You may wonder why we use the same p. Here, p is just a variable, denotes price. But when you evaluate the term, the value of the term, you've got to evaluate at this level, p1. And you evaluate this item, this term, at the value of p of tau minus tau. Okay? Now, we want to rearrange. We just want to rearrange the equation. And we want to find dp d tau. What does it mean by dp d tau? Which means for an increase of 1 unit of tau, when tau increases by 1 unit, so how many units would change in p? Which direction? It goes up or goes down? Is positive or negative? And also, what about the size? What about the magnitude of the change in p? We want to know this. Alright, so here we have a dp d tau, and here we have another dp d tau. And we just rearrange this. Okay, after the rearrangement, we have so exactly the same. Here is what I have rearranged the equation, and this is what we got. Whew. And all right, what is the next equal sign? This equal sign comes from the arrangement of the previous equation. And this equal sign, we just multiply p over q, p over q, p over q in the numerator and the denominator, right? So it's just some manipulation, some simple manipulation. We just multiply p over q together. But this would be a formula of elasticity. So this is a formula of elasticity. Can you see that? Right? So this is the price elasticity of supply. The price elasticity of supply and the price elasticity of demand. Okay? So we call eta is the price elasticity of supply. And epsilon, the price elasticity of demand. And know that know that epsilon is less than 0. Why? Why is epsilon a negative value, a negative number? Why is that? Because the relationship between quantity demanded and price is positively related or negatively related. Negatively, it is due to the law of demand, right? So it's negative. And now we see the formula eta minus epsilon. So we may make it like this. So the absolute value of eta, the price elasticity of supply, and the absolute value of the price elasticity of demand. So it's interesting here. And the math, actually, because they are on the slide, so I will erase this part. Okay? I will erase them. Now let's check. Let's have a check of this term. dp d tau. What does it mean? When tau equals 1, so 1 unit of tau, so the price will goes up from P0 to P1, is that right? Okay? So when this is 1, we'd like to know the size between P0 and P1, and the direction would be positive, right? So how do we know the direction is positive? Because this term, dp d tau, equals eta minus epsilon, which is positive. Alright? So does everyone agree with me that the ratio here is positive? Right? Get it? It's a positive number. So this is positive, which means when tau, the text, increases 1 unit, the P price would increases. Okay? The price increases from P0 to P1. So P here is the price the consumer has to pay. So it goes up. It goes up. By how much? From P1 to P0, from P0 to P1, okay? So now, when this is 1, we like to know, how about this? We like to know the proportion, right? Okay, so we make it as X. And how about this part? It will be 1 minus X. Is that right? Yes or no? Yes. So you remember, this is the part the consumer share of the tax, and this is the seller, the proportion shared by the seller, right? So it's about the tax instance, the proportion by consumer, the proportion by seller, is equals to the ratio of what? Elasticity of demand, which is epsilon, right? And the elasticity of supply. We just derived here. Do you remember this? This is what we just derived. Okay, so now we want to know the value of X. What can we do? We just add the denominator to the numerator to the denominator. So X equals epsilon, eta plus epsilon. Exactly what we have. we just talk about what the consumer share and what the seller share, right? So it is proportional to elasticity of supply, elasticity of demand, and which is eta in the notation that we have, and this is about epsilon, right? So from here, you may easily get x. And x is actually what we need, what we want to know. So this part is x. The change in tau by 1 unit, and the change in tau by 1 unit, and the change in price. Okay, so I hope you may associate this one to this one. Actually, they are the same thing. Okay, let's take a break, and you may think over it. It's 9:52. What about 10:05? Okay, I'll see you in 30 minutes.